So we need to mention one goofy thing about water and the pH of water. That we're always told that the pH of water should be 7. Water's neutral. Well, part of that statement is right, and part of it is not always accurate. Check out this equation. It's the self-ionization of water. There's one component that we haven't really talked a whole lot about, and that's the fact that it is an endothermic process, that there's energy on the reactant side. It's like even in your equation packet, they'll tell you that like Kw is 10 to the negative 14 at 25 degrees Celsius. And it was from this equation, hydrogen times hydroxide equals 10 to the negative 14th. And it's just that in pure water at 25 degrees Celsius, the hydrogen concentration, get that out of there, really is 1.0 times 10 to the negative 7. And it's the same as the hydroxide, 1.0 times 10 to the negative 7th molar. Neutral just means that you have the same amount of hydrogen and hydroxide. Water is neutral. Water will always be neutral as long as it's pure. Now, obviously, when we throw stuff in water, the water can act like an acid or a base. But in just a pure sample of water, it will always be neutral. Neutral means that the hydrogen concentration equals the hydroxide, which, in pure water, 25 degrees, they're both 10 to the negative 7th, and Kw, I'll put that up there too, Kw is 10 to the negative 14th. It's constant. But that's only at 25 degrees Celsius. We know that Le Chatelier would say that if I increase the temperature, that's like adding energy, and I should shift away from energy, which in this case, that would be more forward. If I reduce the temperature, that's like taking away energy, and I would want to shift in reverse to replace the energy. So check this out. In this little table down here, only at 25 degrees is Kw 14, and the hydrogen concentration, and hydrogen concentration 10 to the negative 7th, and pH 7. Oh. But the pH of water is temperature dependent. pH is opposite law of the hydrogen concentration. And if I'm shifting this thing more forward or more reverse, then I'm going to be changing the amount of hydrogen or hydronium in the solution. And so you'll kind of see that at a lower temperature, if I remove energy, this thing should be shifting in reverse to replace energy, right? So check out up here. Here we're going to favor the reverse. And look what happens to the hydrogen concentration. It's smaller, right? Because I have to think that these are 10 to the negative exponents. So 10 to the negative 7.47 is smaller than 10 to the negative 7th, right? So do you see how, like when I shift this thing in reverse to replace the energy, I'm shifting away from hydrogen or hydronium. So the hydrogen concentration goes down, and pH is always opposite log of the hydrogen concentration. The pH of water is not always 7 because the concentration of hydrogen is not always 10 to the negative 7th. Look what happens down here. If I'm increasing the temperature above 25 degrees, now that's more energy, so I'm going to shift more forward. In shifting forward, I'm producing more hydrogen or more hydronium. So yeah, look what happens. The concentration of hydrogen increases. Because again, I have to remember that 10 to the negative 6.76 is greater than 10 to the negative 7. So here you get more hydrogen produced, and the pH is less than 7. But now here's the deal. Water will always be neutral. Water will always be neutral because the hydrogen and hydroxide will always be the same. Whether I'm shifting forward or reverse, I'm always going to produce these guys in a 1-to-1 ratio. If I'm shifting reverse, they're both going to decrease, but at a 1-to-1 ratio. So even at like 40 degrees, I could say that the hydrogen concentration might be 10 to the negative 6.76. Well, so is the hydroxide. Hydroxide would also be 10 to the negative 6.76. Water is always neutral. These guys will always be the same. But the pH will change because pH is based on the amount of hydrogen, and that can't change if the equilibrium is shifted more forward or reverse. The Kw will change because again, if the concentrations of hydrogen and hydroxide are different, I mean, now they're listing a Kw of about 10 to the negative 13.53. That'll change a little bit. The pOH would change. That depends on the amount of hydrogen, the amount of hydroxide, and that can change depending on whether I'm shifting more forward and reverse in response to a change in temperature. But the big takeaway is that water will always be neutral, just meaning that the hydrogen and hydroxide concentrations will always be the same, but the pH will not always be 7.